Colton.
All right, we are going through this now. You still have to do the acceleration due to gravity lab. And we did get one piece of information on that you're going to need. But some of this stuff is just going to, oh, it's frozen. Going to confuse you, so I'll get rid of it. Still might be some stuff that confuses you.
Confused.
All right. We have a problem that a ball is thrown straight up at 253 meters per second. Thank you, Ji Young. That's a very fast ball being thrown.
Wow.
Major league heat. Yes.
Wow.
And they're going to answer, and you can pause the video, and you can answer along with them. How high did it go? How long did it take to get to the top? How long will it take to get back to the original height from the top? And how fast was the ball going when it got back to the original height? So the picture, we've got it thrown here, and it's going to go up to the point where it goes to 0, and then it'll come back down to the original height. We said that up was positive. You can pick either one, but it's probably easiest if whatever motion that the object has at the beginning is positive, so it was being tossed up. We're going to say that up is positive, which makes the acceleration, which you're going to find in your lap, it should be 9.80. You probably won't because you're just using a timer, like on your phone, a stopwatch, and there's going to be some human error involved in that. But since it's being pulled down, gravity always pulls down. Anything in the air is going to have an acceleration of 9.80 meters per second squared. We said up is positive, so it will be negative. Now it's negative on the way up, it's negative on the way down. Anything going down, it's going to be negative. So we are going to take, and like I said, you can stop this and you can figure them all out and then see how well your classmates have done. And I'm going to take and collect all of this, I hope, and pick one of these and group them. Oh yeah. And then put my
All you've left is meters squared. Yep. And a plus sign.
and Casey and Ellen. All right, I can do with or without those, it'll be fine. So for A, Ji Young. Oh, wait a minute, I have to figure this out very quickly. Oh, I don't want that big one. There's my nice little one.
How fast is that?
Take it in yours, just take it times 3.6 and then times 0.6 in the calculator.
Pardon me?
Yeah, you talking to me? Yeah.
I gotta launch that thing.
Yep.
And we get 3 significant digits. All right. So, how far did you get, Ji Young?
I got 12.9 meters.
It might have gone higher than that. Okay, so we know V1 equals 253 meters per second, which, let me write my answer down. Oops. Okay. 253 times 3.6 times 0.6. That's almost 550 miles an hour. something gets shot at 550 miles an hour up, it'll probably go more than 12 meters. Okay, so we know V1 is that, V2 equals 0, and we know that A equals negative 9.80 meters per second squared. Which formula did you choose to use?
I chose D equals V2 squared.
I need to square it.
There you go. So take your answer, just take the answer you got times 253.
253.
Yeah, because you didn't multiply, you multiplied by 253, but you got to multiply it by that one more time.
Oh. 3,265. 27.
You only get 3 significant digits.
327.
So if you have a car worth $3,000, you'll sell it to me for 327?
Shoot, yeah.
Okay.
207.
So did I. That's why remembering to square things is pretty important too. So if your answer doesn't look right, like sending something at 253 meters per second and having it only go 12 meters, she knew that that can't be right. Then look for the first thing if you're using, and she used the formula V2 squared equals V1 squared plus 2AD, which if you put the number V2 I know is 0 equals 253 squared plus 2A is going to be negative 19.6 D. So I move this over and it'll be negative 253 squared. But it's going to be negative once you square that. You don't square it and get a positive there. Over negative 19.6 equals D, which equals 3265.8 or something, and it rounds off to 3. It's going to round off to 3,270 meters, a long way up. All right. So with one silly mistake, we got the answer. Max, how long did it take to get to the top? Wait, hold that thought. Oops, you can't do that. I can do this though. There's Ju Young in a nutshell. Oh, she's going to get the plus sign in the meters per second. Oh. She got a bonus, yeah.
Whoa. Nice.
If Max does well, he'll get the red one. All right, what did you get for an answer?
Did you get? All right, I got 25.8 seconds. Did you get that?
I did. I did.
Oh.
So what formula did you use?
T equals V2 minus V1 over A.
Okay, so T equals 0 minus 253 over negative 9.80 equals 25.816, but we only get 3 sig figs, so 25.8 seconds. Is that actually us?
Yeah, that's us.
That's us. Nice.
I better get that one line.
All right.
Oh yeah, let's go.
Bonus.
Bonus. Geo.
Hi, Gloria.
Hi, Mr. Schmidt.
Hey, you know what? Julie and good old Dave got married this weekend.
Really?
They did.
Really?
In fact, come here.
Oh, come here.
Ah.
Hey, you, come here.
There they are outside of Seattle. That's
Where was
the
their
cabin. Here in Omaha,
Oh.
which is nice.
Is it pretty?
Sure.
Oh.
I wasn't in it. Two of my daughters were in it, so.
Do you want this now?
I do.
Good old Dave.
Good old Dave. That's what my family calls him now.
As they should. As they should call him.
That whole conversation was on.
Hey guys, welcome back. Welcome back to the Schmidt
Welcome
Show.
back. We're back, and it's written different because the computer did an automatic restart, and I lost the other one. But we've already done A and B, and if it's just okay. Hopefully this will show up on the yellow. For A, how high did we actually get to? If you have it down, I remember like 327 or 3260.
3270.
Yeah, that's what it is. So that's not the right color. Oh, I can see it. There we go. 2366. That should have a question mark. And the time to the highest point.
25.8 seconds.
Seconds. And then, so this was JJ.
That one was me. See?
This one
I
was
don't
you.
think I did it right. Yeah. I used the wrong one.
All right. So we are going to do the same thing. I'll do it over here. We're going to go from how long from the top back to the original height. Get them all? Yep. Yep.
Oh yeah, group it.
Oh yeah.
Group it.
Oh yeah. Bang.
Okay, so our picture again is starting from here, going back up and coming back down. And we said that from here to here was 3,270 meters. And it took 25, whoops, no, I don't want.
That was neat.
25.8 seconds. And now Savannah's going to help us out, and we're going to see how long from here is it going to take to go back.
Oh, that's cool.
Go back down. All right, so what we know from there, what do we know at the top
It's zero.
up here?
Yeah,
Okay, so
zero.
V1 at the top equals 0. What else do we know?
V2. No.
We know V2, not yet, not
Hold
until
on.
JC answers her question.
Oh, dang it, JC. We know the distance.
Okay, we do know the distance. It's 3, 2. Now I'm gonna take back the others. You have down what it actually, the calculator actually said, Ju-Young,
You know,
because we rounded it. Nope.
we know
Nope.
A.
Wait, we haven't. We're still working on distance. Let's see if I can find that in here. Another calculator. Oh, did I get it? Oh, good, I did. Oh, 253, well, that's.
Sick.
Okay, distance is 3266 meters. I'm taking back the sig fig that I rounded, and okay, and now we have to decide in this one. Now this is the second part, so we can, on this side, we said that since we were throwing it up, we said that up was positive. On this side, we still can, but that's going to make a difference on this. Right now, we're saying that down is positive because it started here, and we're saying it's good, and we got a positive number here. And you can keep it like that. You just have to make sure you're consistent throughout the problem that you're solving. So Savannah, it's yours. You want up to be positive or
Yeah.
down to be positive? Up? Okay, and I think I just fixed your problem then. So up is positive, but we started with this rock or this ball up here and it came down. So this will be a negative.
Can I just tell you the answer I got for that?
Nope,
Oh,
'cause that would
like it's
probably
wrong.
take that out. I'm gonna ungroup this. There we go. Now I can put a negative sign in there. Okay, so the distance is going to be negative, that, and we also know the A, which is 9.80, but if up is positive, it's accelerating down, so it'll be a negative 9.80 meters per second squared. And we're looking for time. So we need a formula with V1, D, A, and T. We don't have V2,
Me too.
so probably best off using, which one did you use, Savannah?
I used T equals V2 minus V1 over A. That's why I said I got the wrong answer.
You don't know V2.
I know.
Okay, so I would use D equals V1T plus 1/2 AT squared. And you think, oh no, I'm looking for T and I got a T and a T squared. It's going to be quadratic, but it's not, because this is one of those where I had them written up there that you had to do on the last assignment, where what if V1 equals 0, and this just goes away, because V1 equals 0, it makes life a whole lot simpler. So now, 3266, negative 3266 equals 1/2 times this. You will get used to that. Half of that is 4.9, so equals 4.9 T squared. So T equals the square root of negative 3266 divided by negative 4.9. So hopefully that's visible on there. Somebody with a calculator, what is the square root of, well, you can just put them in as positive because the negative signs are going to cancel.
You get 25.8.
All right, so it took 25.8 seconds up, and it takes 25.8 seconds
That's the answer I got.
down.
So I wasn't wrong.
No, you had a negative. You can't have a negative time.
Oh.
Back to the future.
Would it be negative? It's going, oh, thanks.
I thought it was
Time is
negative.
always going in one direction. We haven't got that whole reverse
Yes,
time
negative
figured out.
seconds.
All right, so now we have this. I'm going to leave there. minimize this? There we go. Okay, so our last one is how fast is it going here? But before we do that, you can kind of still just take a little break there and JC and just wait for it. There is another way that we can do the other one. If we do time. Right, we will, if we start with d equals v1t plus 1/2 at squared, this will be our first venture into the world of the quadratic, but we aren't really afraid of that at all. If we are going to start and we want to know how long it took to go from here to here, like just all the way, I put it away, all the way up and down to catch it, the total trip that we were going to go there, what's the displacement?
0.
0. Okay, so the displacement is going to be 0. It's going to end up same place that it started, and equals v1. Now we're going to go with, we went the same on both sides, but up is positive, so v1 is that amazing 253t plus 1/2 of a, which will be, well, I'll just write it out, 1/2 times negative 9.8 times t squared. So I get 0 equals 253t minus
Wait, 1 second.
4.9 t squared. So we rewrite this in quadratic form, it's going to be negative 4.9 t squared plus 253 t plus 0 equals 0. Now I don't actually have to put this one in here, but this is going to be A, B, and we are going to need a C. The quadratic, anytime any one of these terms is 0, the whole thing becomes a whole lot easier. So if I want to know t equals negative b, so negative 253 plus or minus the square root of 253 squared minus 4 times negative 4.9 times 0 all over 2a, which will be back to the negative 9.8. Now, I can rewrite this as negative 253 plus or minus the square root of 253 squared, because 4 times negative 4.9 times 0 is just 0, so that part is just gone, divided by negative 9.8. What is the square root of 253 squared?
253.
Wow, no calculator, that was quick.
Yeah. Because you have that imaginary 2 on the outside.
I can't find how I did it so quickly.
I remember algebra, don't worry.
Okay, so I'm going to use some of this where I started here. We're past that.
Oh, yes.
Nice.
All right, if I do it right, then I'm going to get that with my answer. That's part of my answer.
Bonus.
Max got the bonus yesterday. Whoops, I don't want all of that. Just this. Okay, so if I bring that up, now I've got negative 253 plus or minus 253 divided by negative 9.8. I'm going to get two answers. One if I add and one if I subtract. Both of them are legitimate answers. They're both that we can see in there. If I take and I add this, negative 253 plus 253 is
At 0.
0. So one of them I'm going to get 0 divided by negative 9.8, which is 0. And
Nice.
that's an actual number. If it was divided by 0, that's the empty set, whatever. But if you have 0 on top, then it's 0. Is 0 a good answer when we're at this height? Yeah, that's before he threw it, or she. That was sexist to decide that only a guy could throw it at 253
Wow.
meter,
I believe.
which doesn't really matter because even a guy can't throw
It's fine,
it.
it's fine.
Nobody can, but it's a great problem, Ju Young. We like the 253. So 0 at t equals 0 is before it left the hand, before it was thrown. The other one is the one we're interested in. That's the one that's going to go all the way up and all the way down. So I'm going to take negative 253 minus 253, and I will get really close to 500 and negative 506, I believe, divided by negative 9.8. Now I need some calculator help here.
Got it.
Shouldn't have to be telling you, soldier.
51.6.
Equals 51.6 seconds for the total trip, which makes sense because it took 25.8 up, 25.8 down,
That's a long time.
25.8, 25.8. If I add them, you know what they add up to? 51.6. So you can, if you put in the displacement equals 0, because you're going to end up at the same spot, you will get that. Now you have to go quadratic, but quadratic in this form doesn't take a whole lot of thinking. If you get stuck and it's not a test or a quiz, then you can just ask JC how to do that. But
So it means when you
Or if
throw it
it's on a
up.
test or quiz.
So it means when you throw it up, it's going up for 25 seconds.
oh, that's yeah. No, if you looked at, and this is really fast. Now, hopefully we can get to the potato guns and we can do that. They are going to go 1/5 of this, somewhere around 50 meters per second, somewhere between 30 and 60, somewhere around in there. But even that, I'm going to tell you right now, even if, if we can, it's a really bad thing to decide, hey, I'm going to shoot this straight up.
Yes,
Because
do
it goes up and up, and it can, wait till we get to the next part here, and we're going to see that it's going to be dangerous on the way down, and you can't look up and see it, because here it comes, you don't want it that. But it can be. I've only had one student that and they apologized the whole time with that. It's so stupid, I can't believe I did this, it's so stupid. And they thought, oh, it'll just be funny, it won't be a bad problem. But it's up there for 25, 30 seconds. And that's a long time to watch that, where a whole class, and usually it's 15 or 16 people are sitting there looking down, kind of covering their heads, hoping that no potato was going to land on it. And it didn't hit anybody. It landed about 40 feet away or something, which suddenly seemed very close at the time. But it can, even at that speed, that's a long time for it to be in the air.
How about if you shot someone with it? What happened?
I'd go to jail.
Well, I'm saying, would it like,
Wait, really?
Yeah, that would be assault. You'd probably kill them.
Seriously?
oh my gosh.
50 meters per second coming out. Yeah, a potato, it's a
Can we
heavy
not
object.
do a lab on that? Can we not?
Yeah, well, yeah, it's not going to.
Let's not shoot people.
All right, let's,
There you go.
all right, we got it right, so I get to steal that.
Mr. Schmidt.
Want my bonus?
Oh, yes.
We'll get the bonus figured out.
I don't know, he's gonna get it figured out.
There we go. Group them all.
There you go. Okay.
All right, now, JC, we've hit tape. Thank you for holding. How may I help you?
We picked JC.
Okay, so she's looking for how fast is it going at this point. We want V2 here.
Mr. Schmidt, what value did you? We don't need to do that like that. I just thought you were having trouble saying it.
No.
All right,
What was V1 equal to again? You said?
what is V1 equal to? We're 253 meters.
Oh,
Okay.
oh yeah.
All right,
I think I
so
got it right then.
where did you,
I did the equation V2 squared equals V1 squared plus 2AB.
okay, and we're looking for V2, so I'll put that. What did you use as V1?
V1, I used the, you said 250.
Yep, so you use that 253 squared. It's important not to forget that squared. Plus 2
times negative 9.80 times 0.
times 0 because the displacement is going to end up at the same place that it
So
is.
that cancels that whole side.
Nice. You're going to be a great math teacher.
Then you have the 253 squared, and that's 64,009.
Look at her go.
Okay, but I can also just say that since I'm looking for V2, I can take the square root of this, and I can take the square root of that.
Easy.
I'll do this side, you be working on that other side. Square root of V2 squared is
Oh my
V2
gosh, it's
equals,
so hard.
what's the square root of 253 squared?
I don't know how you did it, JC.
Okay, but now, what do we have to know? Here's algebra going back again. Algebra,
Yeah.
what, because you might have got, what did you get for an answer?
Not that.
Oh.
Oh,
Wait,
wait, leave her alone, Miss 12 meters.
Oh wow.
Okay, forget what you, just, let's go back to this.
Yeah.
How does, remember algebra, what are you going to, what's the answer going to be?
Well, both sides are squared.
Yep.
And you took the square root of
Yep.
both sides. So it should be the 253, right?
Wait, you,
Plus-
wait,
So, but wait,
minus.
somebody else, help her out. When we do in algebra, we take the square root of something,
Oh,
it is
you need to- plus or minus.
plus or
That's what I
minus.
said.
that's why we-
Plus or minus 253. Now you gotta figure out which one does she want.
I want the down.
You want the down, you want the negative, so the answer is negative 253
Wow.
meters per second because there's no way to hit the ground.
Oh. Let's go. What up?
I'm here for class.
Oh.
Yeah, right.
Let's go.
Let's go with
So-
random voice.
It has to be the negative, Hunter, because there's no way to make something hit the ground going up. So it can't be going in the up directions and actually bounce off the floor. So the only way to hit the ground is, as JC said, it has to be going down. So when you have this choice, this one obviously can't work because it's going in this direction. So it is 253. Is that actually true? Not exactly, because air resistance does play a role in this, and it usually is going to come down slightly slower. Now, it depends on what it is. The heavier the object, the closer it's going to be, and the shape also depends on it. Yeah, cannonball would be deadly going like that.
Well, does the wind have a factor in that too? If it's wind?
Not so much in the cannonball. You know,
No,
cannonball
I'm
is
saying
not
like in
going to
general.
be. Yeah.
It's windy, it
It would. Now, if you take a shotgun, and the shotgun is a whole bunch of little pellets going up, the air is going to have a lot more on that. You should not, I'm not saying that it's a smart thing to do, but people seem to celebrate
Yes.
like New Year's by shooting shotguns straight up in the air.
Do it.
And the pellets do come down. It's still a silly thing to look up and wait for them because you're not going to see them come. But most of the time, if you have a hat on or something, they'll just kind of bounce off. I'm not saying you should do it, but they are going to be affected by the wind.
Helmet.
If
Yes.
you take and put all of that shot into a slug, so it's just one big thing coming out of the shotgun, much more dangerous. Do not shoot slugs out of it straight up because it's going to come down pretty close to what it went off at, which nobody wants to get hit with a slug coming down. So theoretically, yes, whatever V1 is here, it's just going to V1 is going to be V2 will be negative V1. They should theoretically be the same, just the opposite sign.
Oh.
So theoretically, up equals down, and the velocity here will equal the velocity there. All right, so since we have love is in the air, everywhere you look around, I'm going to wait until tomorrow to actually put a new set of numbers up there, and hopefully by then I will have grades up out there. I've just about got them all in Canvas, but to put them up there I have to transfer them all to Sick Ed as well. So if you're missing anything, it will show up as a missing assignment. Hunter, you've got a lot of missing assignments.
Never
Your
shows
son
up to
works with
class.
me now.
Oh, you know what? You're doing all right, Hunter. I think we just got you caught
How
up.
much do you pay for the hour?
And
All right.
it's different because I get gas in the truck. So
What's the average?